I'm going to derive the sine law for you and show you how it's connected to what we already know about trig and how we apply trig in right triangles. So we're going to do some work around that. It's not super important, as it wasn't when I derived the quadratic formula for you, that you 100% understand how the sine law is derived, but what is important, of course, is that you can apply it and use it properly. All right? So let's say we had a triangle that looked like this. Sorry. I don't want it to look like an isosceles triangle. And we know this angle is 32 degrees. This angle is 62 degrees. Okay. Because I didn't make that very realistic. There. That matches our data a little bit better. And we have 8 centimeters for the length over here. All right, so let's say our goal was to find side C. First of all, where exactly is side C? Across from angle C. So our goal is to find this side over here. Now, this is not a right triangle. If it was a right triangle, it would be very easy to apply the trig that we already know. It's not a right triangle, so what could we do using what we know about right angle trigonometry to find side C? Yes? Yes, if we drop a height, I'm just going to move this over a little bit so it's not in the way. If we drop a height down here, what we've done now is we've created 2 right triangles with the information that we have. Now, we don't have enough information in the left-hand right triangle to find side C yet. Okay? Is there anything we could find in the right triangle that would be helpful for us to use to find side C in the left-hand triangle? Okay?
The bottom length and then also the height as well.
Okay, I'm just going to put a letter here, D. So you're saying DC or AC?
DC.
DC. How would that help us in the other triangle?
Because then you can get the dotted line.
Okay, but we don't really need to find DC to find the dotted line. So if your goal is to find this line here, we can do that without finding DC. Because remember, in right triangles, all we need is an angle and a side, and we can find any other side in the triangle. And we have that already. Okay? So I like the idea of finding BD, because once we have that, then we have an angle and a side in the left triangle, which would be enough to help us find side C. So let's find BD first. So how do we find BD with the information that we have?
We can use Socrates.
Okay, so narrow it down for me. That's 3 ratios. Which one? Okay, so here's our angle. We want to find this side here, and we have this side over here. So what side are we looking for? And what side do we have? Hypotenuse, so not cosine, sine. So the sine of 62 degrees equals BD, or x, over 8. So BD would be 8 times the sine of 62 degrees. I'm not even going to worry about finding that just yet. I'm just going to leave it like that. Okay, so now that I know what BD is, what would I do to find side C, or AB? It's going to be sine again, because now I have the opposite side and I'm looking for the hypotenuse. Can everybody see that? Okay, so now I'm going to say the sine of 32 degrees equals the opposite side, which is BD, divided by the hypotenuse, which is what I'm looking for, which is CD, or C rather. So I'm just going to write that. I'm going to replace BD with its value, which is 8 times sine 62. So how would I solve this equation for C? Yep. Cameron? I flip it around. You want to clarify that for me? What am I flipping?
No, actually, never mind. That's not a good idea. You could put it so that it's a number over C.
Okay, well, let's leave it as BD over C then, if my long equation's messing you up.
And then
Okay, let's say, for argument's sake, 8 sine 62 is 12. That makes you feel better. It's not, but let's say it is. Because I think visually it's confusing you. So how can we simplified it now? We made it a number. Doesn't matter what the number is, but how do we solve now for C?
you multiply the 12 by C.
Yep. You divide. Think of this as a ratio, right? C times the sine of 32 equals 12 times 1. So we would have to divide both sides by sine 32 to get C. So C is equal to BD divided by sine 32. When I teach this in grade 10, I always say when beside divide. It's a nice little rhyme that helps people remember. Since these are beside each other, I'm going to divide. So C will be 8 sine 62 divided by sine 32. Now, why did I leave that there and not change it to a number? Because I want my answer to be as accurate as possible. And we learned this in grade 10, how important it is not to round our answer, then use our rounded answer to get our next answer, and possibly an answer after that. Because every time we round, we introduce a little bit more error in our final answer. So when we were getting you ready for provincials exams last year, we told you, you don't round until the final step. So rather than worrying about that, and not having to type in this big long hunk of number back into my calculator, I'm just going to leave it and calculate it all in one step. So now I'm going to calculate C. And I'm going to be careful how I do it. I'm going to use my brackets because I want to go 8 times sine 62, get the answer to that, and then divide my answer by the sine of 32. So you have to use brackets to make sure that you get an accurate answer. So C works out to be 13.3, and we are working in centimeters. Yeah, I really didn't care about the answer. I wanted to show you process. So is everybody okay with that process? Remember how we did that kind of work last year? Okay? I'm going to do the same thing with the same triangle, but I'm going to take out all the numbers. And we're just going to do it in generic terms. So if I had the same triangle, ABC, and I'm going to take this step right here, and I'm going to write it in general terms. So this, of course, is side A, side B, side C. So instead of saying the sine of 32, I'd say the sine of what?
C.
Look at the diagram, Tyler. You're so quick to answer without thinking. Look where 32 is. That's angle A. So I put the sine of A. Now 8 represents what? Side A, so that's lowercase a. And side 62 is what angle? C divided by C. So that's this in generic terms. In other words, for any angle and any side length in that triangle. Now, I'm just going to clean this up a little bit, and we're going to have the sine law. So, first thing I'm going to do is multiply both sides by C. So I'm going to get C sine A equals A sine C. And then I'm going to divide both sides by AC. And I end up with sine A over A is equal to sine C over C. Now, that is the sine law. One version of it. So the sine law is very simple. It says this. The ratio, okay, remember we're working in ratios. The ratio of the sine of an angle divided by the side length of its opposite side is equal to the ratio of the sine of any other angle in the triangle divided by the length of its opposite side. So it doesn't matter what angle you do in the triangle. If you take the side of that angle, divide it by its opposite side, you'll get exactly the same value as you would if you took the sine of another angle and divided it by its opposite side. And we got this by doing everything that we already know is true about trigonometry. Okay? So in general terms, for the sine law, we write it for all three angles. So for triangle ABC, and it can be any triangle. Doesn't matter what shape it is. It can be the weirdest looking triangle you've ever seen in your life. It won't matter. It will still work. We say the sine of A is to A as the sine of B is to B as the sine of C is to C. The ratio of an angle, the sine of an angle to its opposite side is identical all the way around the triangle. Doesn't matter what size, doesn't matter what shape, the ratio will always be the same. And it's super easy to use. You're going to love the sine law. In fact, once people use the sine law, they use the sine law even in right triangles, even though it's kind of weird. Sine of 90, which is just 1. It works, though. Some people just get really, they really embrace the sine law. This is a nice thing. All right. So, to use the sine law, you can't use the sine law in all scenarios, okay? You need to have one of a matching pair of an angle and its opposite side. Because if you don't have that, you don't know what that unique ratio is. Because every triangle, that ratio is going to be different. It's going to be the same all the way around the triangle, but the ratio of sides in one triangle is going to be different than the ratio of sides in a different shaped triangle. That should hopefully make sense. So, to use the sine law, you must have the measure of an angle and its opposite side. So if you have that, then you can use the sine law. So let's try. Now there's basically two types of problems. So this would be a type 1 problem, not that it really makes a big difference, but where you're given two sides.
Do you need to measure two angles?
You need, okay, good point for clarification. You need 3 pieces of information in the triangle. All right? In any triangle, in order to solve it, you need 3 pieces of information. 2 angles and a side, 2 sides and an angle. In order to use the sine law, you have to have that matching pair. You could have all 3 angles in a triangle. You couldn't use the sine law to solve it.
Okay.
You couldn't. Right? You have to use the cosine law, which we'll learn in a couple of days. So you're right. You can't, just an angle and a side isn't sufficient to be able to solve the whole triangle. You need one more piece of information. So thank you. That's a good point of clarity. So here's the first type of question where I give you two sides and one angle. So let's draw that. Now the nice thing about this, now that we're not relying on right triangles, we can do all kinds of triangles, including, anyone know what we call this type of triangle? An obtuse triangle, because it has an obtuse angle. Obtuse angles are, careful, greater than 90 is not precise enough.
Between 90 and 180.
Thank you. Between 90 and 180 degrees is an obtuse angle. Okay? I'm going to throw as much geometry at you as I can when I get the opportunity. So this is an obtuse triangle because it has an obtuse angle. And let's say that we know this side here is 3.2 kilometers. So obviously this is not drawn to true scale. 9.6 kilometers. And let's say that this is 110 degrees. Okay, first of all, have we met the conditions to use the sine law?
Yeah.
Yes, we have an angle and we have its opposite side. All right, let's say we want to find side y. So we need to set up the sine law. So the sine law says the sine of an angle. Oh yes, my apologies. What do we want? Let's find angle y. That's better. Let's find angle y. Yes, you're right. Which would be a capital letter. My goodness gracious. What am I doing? Okay, so we're going to find side y, or angle y. So the sine of 110 degrees is to 9.6. That's the first ratio. That's the pair that we have, the matching pair. Now, who can set up the rest of the proportion for me? Kenna?
Equals sine y for over 3.2.
Beautiful. So you got to, as long as you get the angle on the top and the side on the bottom, or you could do it the other way around, right? I could write it. I could flip these over. It wouldn't make any difference. Some people like to put the length on the top and the sine of the angle on the bottom. Makes no difference. And you might see the sine law written either way. Again, it makes no difference. As long as you're consistent from one side to the other. All right, so I need to solve for sine y. How am I going to do that? Yep.
Well, you do 3.2 sine 10, which you cross multiply and divide.
Right, side 110, yeah.
Yeah, and then it would be over 9.6.
Right, so ready to see what she's doing? We're going 3.2 times the sine of 110 divided by 9.6 has to equal the sine of y. That's grade 8, solving proportions. Trust me, you learned this in grade 8. Cross, multiply, and divide. How many times do we do that in grade 8? Yes?
Couldn't you just take the sine of 110 divided by 9.6 and then multiply the answer by 3.2?
No.
Sine 10 divided by 9. Yes, that would work.
Oh, it is?
It would. What he's doing is finding out what that unique ratio is, and then he's applying it to here. Because look, sine 110 divided by 9.6, then multiplied by 3.2, it's going to be the same thing. So if that makes more sense to you, absolutely. No, that's fine. It's good to think these things through. All right, so I'm going to put that in my calculator. So I'd be happy to know this is a calculator part. Most of this unit will be. 3.2 times the sine of 110. Make sure you end your bracket there if you're using the graphing calculators, or a lot of calculators, they put brackets automatically at the beginning. If you don't, and then you hit the divide by sign, then you're going to end up doing the sine of 110 divided by 9.6. So it'll go 110 divided by 9.6, then take the sine. That's not what you want. So those brackets are important. So we get 0.31323, and so on. I'm going to leave it in my calculator. Now, is that a reasonable answer? No. Why? Okay, but that's not y, that's sine y.
Oh.
Okay, did I say this is angle y? No, I said this was sine y.
We're looking for angle y.
Yes, we are looking for angle, so we're not done. So I'm asking you though, is this a reasonable answer for the sine of y? Why not, Renee? Just doesn't feel right? Yeah?
There's like 180 degrees in a triangle, so if that was like that small, then the other angle would have to be like.
Except that this is not y, this is not angle y, this is sine y.
What is sine y?
You have to use the second function to find the measure of the angle.
What is sine y? Interesting.
Wouldn't you like divide, it wouldn't be like that, sorry, 3.2 sine 110.
Okay, if I said sine theta equals 0.3123 and I asked you what's the angle theta, what would you do? We've been doing this for days. Yes? You go second, exactly, second function sine, blah, 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 blah. So we're not done yet, which I said a moment ago. I'm going to come back to this question that I asked him, though. Is this a reasonable answer?
Yes.
What does sine have to be? Well, actually, not technically. It will always be positive in a triangle, though. Why? Oh, there's another excellent question.
Because you can't have negative.
Where is sine positive in the whole coordinate plane? See, it's all going to connect back to what we've been doing for the last quadrant 1 and quadrant 2, which is angles between 0 and 180. Are we ever going to get an angle bigger than 180 in a triangle? No. Is sine always going to be positive? Yes. Okay. So, it's reasonable because it's positive. Still haven't got to my point, though. The values of sine are always going to be in what range?
Is it between the
0 and 1?
0 and 1, yes. Right? Because remember what sine is? Sine is y over r. Or opposite over hypotenuse. That r is always the biggest number. That hypotenuse is always the biggest number. So a number divided by a bigger number will always be less than 1. So, yes, this is a reasonable answer because it's between 0 and 1. It better be between 0 and 1. If it's not, when you go to second function sine that value, you're going to get an error. Well, that was fun. All right, so because we left that whole value in our calculator, we're going to go second sine. Our answer, to get your answer, you go second and then the negative sign. And that's then press enter. So angle y is sine to the negative 1 of 0.31. I wouldn't expect you to write this, but I'm just doing it for our notes. And that is to the nearest degree, 18 degrees. Okay, that looks pretty reasonable given our diagram. Again, it's in the ballpark. Now my diagrams are not drawn to scale, they're just sketched. But even for me, that looks reasonable. Okay? Make sense? Pretty easy, right? Just lots of little bits of simplifying, and that's about all. Other than that, I think it's pretty straightforward. Okay, other type of question, then you're going to try one. So I'm going to call this type 2. Is where you're given two angles and one side. So, as we said before, you need 3 pieces of information. So I'm just going to give you different pieces of the triangle this time. Trying to make my diagram look a little bit more authentic. All right, so that's 8 degrees. Yeah, no, it's a really big degree sign in relationship to the 8. Can't make a smaller circle, I just can't do it. Sorry. Okay, well, hadn't got that far yet. They were criticizing my 8. Okay, so we are going to find side n to 1 decimal place. Okay, so have we met the conditions to use the sine law? Okay, we have an angle P at an opposite side of 28. So we go the sine of 12 degrees is to 28. Now our goal is to find side n. So what's the other side going to look like?
Sine 160 over.
It's not fair. She knows what she's doing. Okay, gotta let everybody else catch up though. Okay, so we don't have angle n. Are we hooped? Nope, clearly not, because she figured it out. We can always find, if we have 2 angles in a triangle, surely we have 3. Yes? Because they all add up to 180. So we can calculate that angle n is 180 minus 8 minus 12, or 160 degrees. So sine 160 degrees is to side n. All right, find side n for me. Finish it off. Anybody have n for me? Cameron?
46.1.
Gonna finish that for me? I feel like I'm hanging.
Centimeters?
Well, I said 1 decimal place, so I'm okay with this rounding. I'm just sorry.
Centimeters?
Thank you. Lengths don't mean anything without units. Yes.
How do you get n equals 28 sine 160?
This times this divided by that.
Okay.
Right? Cross multiply and divide. Yes, Marie.
Do you have to show that stuff or can you just
Yes. I want you write this, you write this, you write this. Yes.
Why can't you just multiply sine 160 to the first part of the equation?
What do you mean? Sorry. Well, because it's the same thing. All you're doing is you're doing the division first and then the multiplication. Doesn't matter.
If I didn't get that. Fine.
Okay. Then you have to make sure you get the full answer and then multiply by 160. Oh, hang on. What is? No, it should work. If you go 28 divided by sine 12, get the answer to that, multiply by sine 160, you should get the answer. Okay, yeah, well, yes.
How do you know that sine 12 divided by 28 equals sine 160 divided by
So that's the sine law. Sine law says the sine of an angle divided by the length of its opposite side is equal to the sine of any other angle than triangle divided by the length of its opposite side. Right? Sine A is to sine A is to A is sine B is to B. That's all we're doing. Okay, we're running out of time. So I'm going to give you an example, but we need to explain one more thing to you before you do that. We do that. What does it mean to solve a triangle? We did it last year.
Find all the angles.
Okay, Tyler. You both. It's one I blurt. Give people time to think, process, throw up a hand. When I think the time is right, then I'll let you answer. So what does it mean to solve a triangle? We did it in grade 10. So think back. Chapter 3, first term. That was a little ways back for some of you. If I asked you to solve the triangle, I was asking you to do what? Yes.
Solve all angles.
So find all the missing sides and all the missing angles. So to solve a triangle means to find all its pieces. Okay? So it means to find all missing sides and angles. All right, so this is the one you're going to try. I want you to solve triangle ABC with this given information. Okay, so find for me all the missing pieces. Quickly now, because we're almost out of time. Cam just asked a really good question. He says, when you're looking to find, say, side B, does it matter whether you use angle C with side C or angle A with side A? No, it doesn't matter if you found all the other pieces correctly. So to be super cautious, careful, I would always use the information given as much as possible because I know that's right. Okay? In case I made some silly mistake in finding angle C, for example. Of course, if I'd done that, I've already messed up because now my angle B is going to be wrong too. But so if you can, use the information given, if possible. It won't always be possible. At some point, you're going to have to take a leap of faith that your answer is correct. All right, we haven't got a lot of time, so I'm just going to write down the answers and you can check to see if you got them correct. So angle C, 37.9 degrees. Angle B, 94.1 degrees. Yeah, let's talk about that in just a second. And B, 29.5 degrees. So if this was a question in the textbook or on a test or a quiz, it would give you the rounding expectations. Okay? So you would follow the rounding expectations in the question. So it'll say round to 1 decimal place, round to the nearest degree. It's nice to not round too much when you're using one answer to find another answer. Again, because you get, the more you round, the more likely you are to be a little bit off in your answer. So if you're asked to go to 1 decimal place, you might even want to go to a couple decimal places and only round after you've found all the other pieces of information. All right, that's all the time we have. How many people got those 3 pieces correct? Awesome. So it's really not hard to use. So we are only doing a portion of this section because there is one type of question. It's called the ambiguous case. Anybody know what the word ambiguous means? Anybody? Ambiguous? Yes?
Having a vague meaning.
There you go. Not clear, right? So ambiguous.